So firstly, thank you to Karina for organising another excellent City Quantum Summit. It really is a pleasure to be here to wrap up the day. I'm Dr. Harriet Vandervliet, and I'm the Product Segment Manager for Quantum Technologies at Oxford Instruments. So we design, supply and support market-leading research tools that enable quantum technologies, new materials and device development in the physical sciences. Our tools support research down to the atomic scale through the creation of high-performance, cryogen-free, low-temperature and magnetic environments based upon our core technologies in the low and ultra-low temperatures, high magnetic fields and system integration with our ever-increasing levels of experimental and measurement readiness. So we're a world-leading provider of dilution refrigerators and superconducting magnets, and we provide the low temperature for quantum computing modalities such as superconducting qubits and silicon-based spin qubits, but also for quantum technology research. But alongside the manufacture of products for use in quantum computing and quantum technologies, we're a member of different consortia, including as founding members of UK Quantum, which is the voice of the quantum industry in the UK. But I also personally am a proud member of the Institute of Physics. I'm a quantum physicist. I've been a member for a very, very long time, and I sit on the steering committee for the Quantum Business Innovation and Growth Group. So the QBIG Group is a member-driven group supporting the growing business community of industrial quantum physicists, engineers, innovators, entrepreneurs, but also the curious who want to know more about this sector. These consortia and groups are really important to us at Oxford Instruments, as it not only encourages education and collaboration, but also supports emerging technologies and new companies, which we will hear about soon. An example of this is through the IOP QBIG Prize for Quantum Innovation, which is sponsored by Quantum Exponential. You've already heard from Quantum Exponential's Stuart Wood, so I won't say too much more about them, other than to thank them for the ongoing support of the QBIG Prize. So I'm delighted to announce that the second QBIG Prize is now open for applications. The QBIG Prize is awarded to small and medium-sized companies working on taking quantum technology products or solutions to market. The winner will receive a cash prize, mentoring, and access to the IOP's Accelerator and Business Network. We look forward to the nominations for next year's prize, and you can find out more online on the IOP website. So the first and inaugural winners of the prize were Circa Magnetics. Circa Magnetics are a spin-out from the Nobel Prize-winning Sir Peter Mansfield Imaging Centre at Nottingham University. They use quantum sensors to make the world's most advanced functional brain scanner. They've developed and brought to market now the world's first commercially fully integrated brain imaging device based on optically pumped magnetometers, the Circa OPM MEG system, which I'm sure you will hear more about. To talk more about this prize and to tell us what winning the prize has done for Circa Magnetics is David Walger, the company's director. So if I can hand over to you.
Thank you. Thanks, Harriet. So to tell you a bit about Circa Magnetics, we've heard a lot about quantum computing companies today. Circa Magnetics are a biomagnetic imaging company. As Harriet said, we use quantum sensors to look at the magnetic fields within the body, and initially we're focused on looking at magnetic fields within the brain. Now the brain, in the human brain you have 300 million neurons. It's the least understood organ in your body. So probably a difficult area to focus on initially, but we feel there's most opportunity in this area to really make a societal change for good using quantum technologies. Circa were formed in July 2020, so not only are we looking at a difficult organ in the body, but we also formed in the middle of a pandemic, which probably wasn't the thing that most people were thinking about doing as they were kept at home. A standard question we get asked is, how is this different to MRI? So MRI was actually discovered in Nottingham and developed in the Sir Peter Mansfield Imaging Centre in Nottingham. What you actually use there is a big magnetic field to look at the brain structure or structure within the body. What we're actually doing is looking at functional activity within the body. So we're really looking at what's going on within elements within the brain. So if you move your left hand, your right motor cortex is actually operating that, and we can see what is going on using our sensors. This is important for things like epilepsy, dementia, Parkinson's. So as an example, children with epilepsy at the moment would have an EEG scan that looks at the electrophysiology. The challenge there is that actually the skull causes problems with what you're able to see and the depth that you're able to see. Our technology uses the magnetic fields within the brain. We're able to see much deeper, we're able to see that structure much better, and we've already begun to show with some of our early adopters of this technology how it can actually be used to help children suffering from drug-resistant epilepsy. There's further work going on with dementia and longitudinal studies to look at changes within the brain over time. Unusually for a quantum company, we're actually making money. In our first year of trading, we delivered systems to Sick Kids Hospital in Toronto and Young Epilepsy, a specialist charity in the UK. Since then, we've delivered further systems to Yale. We've got one system going in at Princeton in the next couple of months as well. So we've really got some key early adopters for this technology who are now working with us in order to work out the biomarkers. Fundamentally, our system enables you to see what's going on within the brain, but ultimately we need the specialist neurologists to be able to look and understand what that actually means and almost translate that into a ability to make a change and to actually look at things like how drugs can be used to treat dementia. If you can see, you can arguably make those decisions much, much quicker. So in a drug pipeline, you can make the decision to move on quicker. Epilepsy specifically, potentially there's an application to look at surgery and surgical removal for very young children. So we've scanned down to 6 months old and we've had very good success in 2 to 4 year old children where we've been able to look at things like autism at Sick Kids in Toronto. So the actual challenge for us at the moment is delivering. We're still a fairly small startup company and we've got over sort of 10 of these systems to deliver in the next year or two. So it's very challenging going from a university team to actually a company and then actually being all over the world delivering these systems and learning how we actually support them and deliver the software and the solution for the neuroscientists. We were very pleased to win the IOP prize last year, and Quantum Exponential, thank you for sponsoring that prize. The money and the support as a result of that prize really is helping us to take this technology forward. We're working along with the prize money, but also an Innovate UK funded grant to now work on the clinical approval process for this technology. We really hope as a team that this will be in every hospital and potentially every doctor's surgery, a bit like MRI when Sir Peter Mansfield discovered this in the 60s. It boomed, and the uses as we were able to use this technology really we feel has unknown potential and will only go further. Outside the brain, there's also the ability to look at fetal imaging and muscle imaging and other areas of the body. So already we've had some success with a partner in Arkansas at fetal imaging and using that for identifying diseases potentially in fetuses prior to them being delivered. Again, knowing this early helps these issues to be sort of treated as early as possible, and fundamentally that's what we're trying to do. So yes, the money from the IOP will really help us with that, as well as the sort of business support from Quantum Exponential and the guidance and advice from them. I think this has a real opportunity to make a change for the UK economy. We've developed this technology in the UK, and we really are very focused on delivering it as a UK company, despite the fact that we're delivering these systems all over the world. It's the cutting edge technology has been developed and optimized within the UK, which is really good to have been part of. I think the summary maybe for me at the end of a quantum showcase type event is actually the important thing for us is that our customers are no longer speaking about quantum. They're speaking about what the system can actually do for them. I think the success of quantum will come when we almost no longer talk about the quantum nature of the device. We talk about what the devices can do. So how can that system help with brain imaging in children? How can that help in fetal imaging, etc.? And that will be when we've really made a success of quantum technology, in my view.